Assalamu alaikum, teacher.
Hello, Assalamu alaikum. Are you all able to hear me?
Yes, ma'am.
Yes.
Okay, how are you?
Alhamdulillah.
All right. Let me know when the screen is visible. Yes, is the screen visible to all?
Yes.
Okay. Today we're going to start off with the chemical energetics, and this basically involved the chemical reactions. We're going to look into the chemical reactions, their enthalpy changes, and how the energy exchange basically takes place. Okay. So when you primarily categorize the chemical reactions into two different categories according to the heat exchanges or energy changes, they are mainly categorized into two dimensions, that is exothermic and endothermic. Okay. Now, thermic, as you look, if you decode this terminology and you look into this, thermic basically refers to heat energy, right? That is thermal energy or heat energy, you can say. Whereas exo means there is exiting of heat energy. And if you look into endothermic, it means that there is entering of heat energy. Okay. So remember from this En and Ex. Okay. Exo means exiting of heat energy and endo means entering of heat energy. Now, where is this heat energy exiting from and where is it entering into? When you look into a chemical reaction and you look into a chemical, for instance, if you have a mixture, right? So the region where this chemical reaction takes place or your chemical mixture basically tends to be the system. Okay. This is the system where the chemical reactions they are taking place, right? And anything outside the system, anything which is present outside the system is going to be your surrounding. Okay. So when you say that a reaction takes place, for instance, I say that reactant A and B, they react with each other and then they form a product C. Okay. A new product is formed, which is C. So both of these reactants must collide with each other and they should have sufficient energy to have a successful collision and then form a new product. There is likely possibility that when two different reactants they react with each other, they collide, they are colliding with each other, but they are unable to form this new product C. Is this point clear so far? Is the second point clear so far? I said that when two different reactants they are colliding with each other, but there is a likely possibility that the collision is an unsuccessful collision and the product C is not formed. Okay. So these are the two different case scenarios, right? So A and B, both of them, they are colliding with each other. And then supposedly they are forming this new product, which is product C. Okay. Now there is two different concept I need to give here at this point. When both of the reactants, they are colliding with each other, they must have sufficient energies, sufficient kinetic energies to collide with each other. And the collision must be a successful collision to produce the new product, that is C. Okay. So when the two different reactants, they are reacting with each other, their old bonds will be broken, right? And new bonds will be formed. For instance, I say hydrogen gas and there is chlorine gas. Okay, both of them, they react under certain conditions, and a new gas is produced, or a new product is produced, which is hydrogen chloride. So this means that both of the hydrogen molecule and the chlorine molecule, both of them, they have broken their old bonds to produce this new bond. Okay, and this new bond is with of the product bond, that is hydrogen chloride, right? Is this point clear so far? Give me a yes or no.
Yes.
Okay.
Yes, miss.
Now, how is this whole concept linked to the system and the surroundings concept? When we say that this reaction is taking place, these old bonds, they are broken, and then new bonds, they are formed. Sometimes the reactants, they do have sufficient energy to collide with each other. They have energy that is the minimum energy which is required for the reaction to take place, and that is referred to as the activation energy. Okay, so basically you can say, to understand the concept, you can say that reactants actually require activation energy, which is a minimum amount of energy to basically activate the reaction. Okay, when the reaction is activated, a new product is formed. Okay, so this minimum amount of energy is required by both of the reactants to produce this new product. If supposingly the reactants, the second case scenario, if the reactants, they don't have this minimum amount of energy, that is the activation energy, they have energies less than the activation energy, then this new product will not be formed. They will be colliding with each other, but they will have unsuccessful collisions. Okay. So what must be done to produce this product? So to produce this product, their old bonds needs to be broken down, right? This means that they need to take in or absorb heat energy from their surroundings into the system to break their old bonds and then produce new bonds, okay, or form new bonds. So this bond breaking process basically requires heat energy. So there is entering of heat energy, and we say that the bond breaking process is basically an endothermic process. Okay, any bond breaking process is the endothermic process. Okay, and when new bonds they are formed, whenever new bonds are formed, this process is an exothermic process, which means that when new bond there that is formed, the system is going to release heat energy into the surroundings. Okay. So exothermic means that the energy is being released from the system to the surrounding. This is exo. Okay. And whereas endothermic means that the system is taken in heat energy from the surroundings. So there is entering of heat energy into the system from the surroundings. All right. Is this point clear so far? Okay.
Miss,
Yes, Zoya.
when the bonds are being made, it is exothermic.
Yes. Bond making or bond formation is exothermic.
Okay.
All right. Now, let's look into some of the theory part, and then we're going to move on to the whole case scenario. So we know that the chemical reactions, they basically take place. Why do the chemical reactions they take place? Because the reactants, they need to fulfill, they have the aim to fulfill their outermost shell, right? That is the valence shell. And they do so by forming new bonds. And to form new bonds, their old bonds needs to be broken down. So we say that hence chemical bonding basically takes place. And this whole process or the chemical reactions which occur, this process basically involves the transfer of heat energy or the thermal energy, which is either into the system or out from the system into the surroundings. Okay, and the energy within the system comes from the chemical bonds themselves, right? So this can be considered as tiny stores of chemical energy. When you look into exothermic reactions, they are that the thermal energy is transferred through the system from the from the system into the surroundings, which means that obviously if you are giving heat energy or there is maximum amount of heat energy which is being released, this means that the temperature of the surrounding tends to increase. Okay, so your reaction mixture is going to feel hot. Okay, this energy is then transferred from the chemical energy store of the chemical system to the surroundings, and so the energy of the system is going to fall. As a result, we say that the delta H or enthalpy change tends to be negative. Okay, whenever there is exiting of heat energy, the overall enthalpy change tends to be negative. How do we consider that this the whole chemical reaction, is this an endothermic reaction or that reaction is an exothermic reaction? By looking into the energy which is taken in to break the bond, and by looking into the energy which is given out while forming the bonds. If supposingly I say that the reactants, they already have some amount of energies that they possess, and only minimal amount of energy is required, so less energy is taken in by the reactants. Okay, and when they produce new products, they are going to release maximum amount of heat energy, which means that the energy which is taken in is less as compared to the energy which is given out. Okay, when you compare both of these processes, all right, when you compare both of these processes and you find out a change in this energy, in both of these energies, the energy which is taken in and the energy which is given out, then you get to know the delta H value, or you get to know the enthalpy change, okay, the energy change. So the energy which is taken in by the system is very less as compared to break the bonds, as compared to the energy which is given out or exited from the system into the surrounding, hence producing greater amount of heat energy. And we say as a result that the total energy change or enthalpy change tends to be negative. Is this point clear so far? Okay. Moving on to what are the chemical reactions which are very typical of exothermic. For instance, when you look into the question papers, or if you go through your past papers, you are going to analyze a few things. Usually it is asked in your paper 2 and paper 4, where the MCQs and the subjective paper, the theory paper, they are going to mention that this reaction is which reaction is going to be exothermic in nature, or they're going to give you a chemical reaction and they're going to ask you whether this reaction is exothermic or endothermic. Just by looking at the chemical reaction, or if you remember the typical chemical reactions which are typical of exothermic and typical of endothermic, you will be able to identify. For instance, combustion reactions, oxidation reactions, and neutralization reactions, they tend to be typically exothermic. Okay? In chemistry, we do have exceptions, but the typical reactions for exothermic category is going to be combustion reaction, oxidation reaction, and neutralization reaction. For instance, if I say that methane undergoes combustion, or it reacts with oxygen to produce carbon dioxide and water, this means that this reaction has to be combustion, which is going to, or you should develop this in the reflexes, that since this reaction is combustion reaction, which means that the delta H value has to be negative. This will lie under the bigger umbrella of exothermic reactions. Are we clear?
Yes, miss.
Okay.
Yes.
So by looking into this reaction, you are able to identify, by looking into this diagrammatic representation, you are able to identify that the heat energy is released from the system into the surroundings, which means that the temperature of the surrounding tends to increase, and this container or this conical flask is going to feel hotter. okay, as compared to the surroundings. This means that this kind of a reaction is an exothermic reaction. Whereas if you look into the endothermic reactions, the thermal energy is taken in from the surroundings. Why do the reactants, they basically need more and more energy? This means that the reactants, they have less energy as compared to the products, okay? They require greater amount of energy to be activated to produce this product, okay? Which means that the activation energy which is required is by the reactants to produce the product is actually greater as compared to in exothermic reactions, okay? And if you look into this, the energy which is taken in as compared to which is given out is actually more, okay? More energy is taken in to break the old bonds as compared to the energy which is released when new bonds are formed, new product bonds they are formed, okay? So overall, if I say, if the energy which is taken in is actually greater, this means that your delta H value tends to be positive, okay? Your delta H value or the enthalpy change tends to be positive because more energy enters into the system as compared to the energy which is given out. Typical reactions for for endothermic processes, they are electrolysis, thermal decomposition reactions, and some of the stages of photosynthesis. For instance, if you look into thermal decomposition, a very common example is ammonium chloride. When ammonium chloride undergoes thermal decomposition, it produces ammonia and hydrogen chloride. Okay, so in this case scenario, this means that this ammonium chloride, for it to be thermally decomposed to produce its products, the amount of heat energy which is required to thermally decompose it is actually greater. Okay. If you look into some practical case scenarios, you must have seen some sports injuries, right? And cold packs, they are used. And in cold packs, this reaction basically takes place, okay? And since this reaction is an endothermic process, this decomposition of ammonium chloride, which is why the cold packs, they basically help the knee injuries, specifically the kneecap injuries, where if you get a swollen kneecap, right, and you place the cold packs over there. Why is that so? Because it's going to help you prevent further swelling to be developed. Okay, it is going to take in heat energy from that from the surrounding, all right, from your kneecap, and it will be used to do this endothermic process. Okay, moving on. If anyone has any questions by far, let me know, please. Yes. Any questions so far?
No.
Okay, let's move on furthermore. So we have basically discussed these various factors, that is energy, the orientation of the molecules or the reactant particles, or the number of collisions and everything. The number of collisions basically is the frequency of the collisions. The more frequent the collisions are going to be, there is a likelihood that or the probability of the products being formed is going to increase. Okay, the greater the energy of the reactants is, this means that they're going to obviously have greater number of collisions and they will produce the product. Okay, one thing more which the reactants must need is the activation energy. Their energies must be either at least minimal of the activation energy, or they must have energies greater than the activation energy for the reaction to proceed. Okay, if you look into enthalpy changes, this is better explained in this reaction profile diagrams. Reaction profile diagrams are graphical representations of these exo and endothermic reactions. Okay, now if you look into this, this basically tells you the energies of the reactants and the product, which lies on the y-axis, as for the progression of the reaction. Okay, so we say that supposingly if reactants, they have greater energy as compared to the products. Okay, So products, they have relatively less energy as compared to the reactants. This top hump that you see is basically the transition state, right? Which transition state? I told you that when a new product bond is formed, so they are trying to form their new the new product bond, right? This bond formation happens in new bond formation, and old bond breaking happens in this transition state. Okay, so old bonds, they are being broken down, and new product bonds, they are being formed. When this much amount of energy, which is the energy which is required by the reactants to produce the products, is referred to as the minimum amount of energy, is referred to as the activation energy. So this energy profile diagram, where you see that the reactants, they have greater energy as compared to the products. The activation energy is also very less. This means that the reactants, they already possess greater amount of energy, and less energy is taken in as compared to it is given out. How do we say that? Since we are able to notice that the overall energy change which takes place, energy change is always, or the enthalpy change is always between the reactants to the products. Okay, so always between the reactants to the products, this area or this change in enthalpy or energy is referred to as your delta H, or delta means change and H refers to enthalpy. So this is going to be the enthalpy change of this reaction. Whenever the enthalpy change of the reactions tend to be negative, or you see that the arrow goes downward, this means that the delta H value has to be negative, and this energy profile diagram has to be exothermic. Okay, are we clear so far?
Yes.
Okay, so these points, they are very important. You should remember these points. If the reactants, if they are greater than the product, their energies are greater than the product, what reaction is it going to be? And if the energy is taken in less as compared to it is given out, then you should know that this is also exothermic, basically. Okay, let's look into the energy profile diagram for endothermic reactions. If you look into this one, for the progress of the reaction, now here you are able to notice that maximum amount or even greater amount of activation energy is required by the reactants. Okay, so this only takes place in endothermic reactions, where all the energy is heat energy is being absorbed from the surroundings into the system, and to basically use that or utilize that energy by the reactants to break their old bonds, right? Then only this transition state is going to take place, and then the new products will be formed. The reactants, they have less energy as compared to the products, and the delta H value is going to be positive. Why? Because now the products, they have greater energy. So this means that less energy was actually given out, more energy was taken in. Okay, and hence as a result, delta H value has to be positive. Okay, delta H is going to be an upward arrow, and your EA is always from the reactants to the top hump. Your EA always has to be the energy which is from the reactants to the top hump. Okay, till the transition state. So now let's discuss something about bond breaking and bond forming. When a reaction basically takes place, whether it is be it exothermic or endothermic, it completely depends upon the difference between the energy which is needed, right? So overall reaction, I've told you two different things. I told you in the initial stages that bond breaking process is an endothermic process, but bond forming process is an exothermic process. But when I ask you whether the reaction is an exothermic reaction or an endothermic reaction, then you're going to look into how much energy is taken in and how much energy is basically given out. And when you're going to when you are able to find out the difference of these two energies, then only you can comment whether the reaction is an exothermic reaction or an endothermic reaction. Is this point clear so far?
Yes.
Okay. So when supposedly if I say that more heat energy is released to the system, to the surroundings While forming new bonds, this means that the reactant has to be exothermic. And when I say that less heat energy is released into the surroundings as compared to it was taken in, this means that the reaction has to be endothermic. Okay. Any questions by far? Do we have any questions so far? Yes, Ayla, Basit.
No, ma'am.
No.
Okay.
Yes, Miss, I have one.
Yes, Zoya.
So, in the exothermic graph, for the enthalpy change, do we make a double-sided arrow or a downward arrow?
Come again. What did you say?
I'm saying that in the exothermic graph, for the enthalpy change, do we make a downward arrow or a double-sided arrow?
No, no, no. Don't make a double-sided arrow. It is always, it has to be this downward arrow. I made this arrow to represent basically or to illustrate that it has to be only the difference between the reactants and the products. Why? Because when the options they will come up, okay, they might give you this arrow as well, okay, this whole complete, this is not the correct way of representation of delta H. Delta H always has to be basically the difference between the reactants to the products, okay. And since the final energy which of the products is less than the reactant, so the arrow points downwards, okay. But for instance, if you look into the endothermic reaction, the final product energy is greater than the reactants, which is why the arrow points upwards, okay. So the delta H value has to be positive. We are going from less energies to greater energies, from reactants to products, right? So which is why delta H value has to be positive in endothermic, whereas it has to be negative, that is a downward pointing arrow in exothermic reactions. Clear?
Yes, Miss.
Okay. Now let's move on to bond energy calculations. Now, for instance, the bond, usually there are two dimensions in which the examiner can ask you questions here. What is that? You will either be given the bond energies table, okay? All the bond energies, they are basically in kilojoules per mole. And what is bond energy? Bond energy is basically the amount of energy that the bond possesses or is required to or the energy which is basically required to break that particular bond or 1 mole of bond, okay. So if supposingly they are either going to give you this kind of a scenario where they're going to tell you all the bond energies for the relevant bonds, okay, for the question, and they will ask you to find out the enthalpy change of the reaction. Either this is one possible case scenario. Other possible case scenario is they will give you the reaction, okay, and they also give you the delta H value as well, okay. And they will ask you any particular bond energy, okay. You will be asked to find out the bond energy by using this delta H value and the rest of the bond energies. So we will look into both of these, how this can be contemplated. So for instance, if whenever these calculations you're going to start off with, you always must have a chemically balanced equation, all right. The chemically balanced equation will be provided by the examiner, and you will be asked to find out, if supposedly you are asked to find out the enthalpy change, that is delta H value. And then you will be asked to give determine whether the reaction is an exothermic process or is that an endothermic process. Just give me a minute. I should take a call. Just give me a minute. Okay, yes. So we were basically talking about the enthalpy change. So for instance, if you look into this question here, it says that hydrogen and chlorine, they both react to form hydrogen chloride gas. Okay. The bond energies are given to you, which is the standard, that is kilojoules per mole, can also be asked in joules per mole. You have to look into the context of the question. So if you look here, it says that hydrogen and chlorine, both of them, they react with each other and hydrogen chloride gas is formed, right? Now, 2 moles of hydrogen chloride gas is formed. The easiest way out is that you just simply draw the displayed formula. Okay. So you are able to know what bonds are present. All right. So for instance, yes, there is hydrogen-hydrogen single covalent bond and chlorine-chlorine single covalent bond. Now they produce 2 moles of hydrogen chloride. This means there are basically how many bonds of hydrogen chloride in total which are being produced? Can someone tell me?
1, like HH 436 1.
No, how many more, how many bonds of hydrogen chloride are being produced?
Oh, that's 2.
That is true,
Yeah,
right?
2. Sorry.
So the bonds which are broken down are this single covalent bonds of hydrogen molecule and chlorine molecule. This means that the energy which is taken in is basically this much amount of energy for one hydrogen, okay, and one for chlorine. So this bond energy is going to be 436 plus 240, right? Whatever the answer comes up, you're going to write it down or present, mention as the energy which is taken in, okay? Or it is absorbed. Tell me the answer. 436 plus 243.
679.
679. So we're going to mention that this is 679. And how much energy is released? So it's 2 times the hydrogen chloride bond, right? So it is going to be 2 times 432. Yes,
864.
860. This is the amount of energy which is given out. This means that more amount of energy is given out or it has exited as compared to which is absorbed for bond breaking, right? So to find out the value for delta H, it is going to be energy which is given in or simply in minus out. Okay. You're going to place the both of these answers here. That is going to be 679 minus 864. Whatever the answer comes up is going to be your delta H value. What is it?
Negative 185.
Yes, it has to be. You have to mention this after mentioning all your steps and everything else. Lastly, when you're going to mention your answer, negative
185.
185. So negative, this sign has to be mentioned, your numerical value has to be mentioned, and lastly, your units. What are the units? They're going to be kilojoules, right? Is this point clear so far?
Yes.
Okay, let's all right. If you look into this question here, it says hydrogen bromide decomposes to form hydrogen and bromine. If you look into this, this says it decomposes to form hydrogen and bromine. This means that it refers to that thermal decomposition has taken place, okay? Or it is thermally decomposed. This means your delta H value will be
Positive.
positive. It has to be positive. We said that generally the thermal decomposition reactions, they're typical reactions of endothermic processes, okay? So here, if you look into all of these bond energies, can anyone tell me the answer for this one, for the delta H value?
103.
Positive 103.
Yeah,
Yes.
positive 103.
Yes. What did you do here?
I did for delta H value 2 multiplied by 366, which is HBr. We have two bonds of that. Then I subtracted it from the energy which is released, like 436 plus 193, and I subtracted it. So I got the answer positive 103.
Very good. So this means your this particular reaction here is basically an endothermic reaction, which is why you got the value of delta 18 positive.
Yes.
Right. Okay. So let's do a few questions related to this. There's one more thing that I need to. Wait, let me just share one more thing. I have checked your papers as well. And I have sent you all your evaluations. But some of the questions, they were like very common questions which you guys were not able to answer. So let me just open it up. Yes, let me know if the PDF is visible.
Yes, it's usable.
Okay. All right. This question, if you look into. These are very straightforward questions. The first part and the second one. What is the, which oxide is this? Copper 2 oxide. Metal oxides, they tend to be basic oxides, right? And the Roman numeral 2 is basically your oxidation state or oxidation number of copper here. Okay. You have to mention complete thing. They did not ask you state the meaning of the Roman numeral, but they asked you in which context? In this context, that what is copper in copper 2 oxide, in the name copper 2 oxide. So you have to mention completely that it is basically the oxidation number or oxidation state of copper, that is +2. Okay. Then this was also easy. Mass of this much number of moles. So moles in mole mass times the molar mass is going to be your mass is equals to moles times the number of the MR, right? So this has to be mass in grams, right? But the next question said, calculate the total volume of gas in decimeter cube at room temperature and pressure. I think only one or two maybe they were able to write correct answers, but most of the students they didn't do it right. Calculate the total volume of gas in decimeter cube at room temperature and pressure which is produced when 0.02 moles of copper 2 nitrate is heated. Now, if you look into this, they have asked you the total volume of gas which is produced. Now, look into the context of the question again and look into this stoichiometric equation that they have given to you. There are two different products which are gaseous products. Okay. And these are the gaseous products which are produced. This is the gas which is produced, right, from thermal decomposition of copper 2 nitrate. So, according to this reaction, 2 moles of copper 2 nitrate, we have the coefficient 2, which produces approximately 5 moles of your gaseous products. How? 4 moles of nitrogen dioxide, and when nothing is written as a coefficient here, this means this is 1, right? So 4 plus 1 is going to be 5 moles of gaseous products are formed or they are produced. Okay. Then they say when 0.02 moles of copper 2 nitrate is heated. So this means that I'm going to mention 0.02 moles here of copper 2 nitrate. How much moles of this will be or shall be produced, right? Then you're going to cross multiply this, which means that the number of moles of gaseous products is written as X here, which has to be 0.02 times 5 divided by 2. Okay. This will give you the actual amount of moles of gaseous products which are produced. By using these number of moles, whatever the answer comes up, then you're going to multiply it by the moles times 24 gives you the molar gas volume, that is 24 in decimeter cube, gives you the volume, total volume of gas which is produced at RTP in decimeter cube. Okay, so this answer has to be placed here and then will be multiplied by 24. I'm just giving you the concept. Okay, you can solve it at home. Is this point clear so far? Yes. Okay. Next, moving on to this one. Write the simple equation for this reaction. Now, powdered aluminum reduces copper 2 oxide. Aluminum, it is Al. Most of the students, they were able to guess the reactant side correct, but in the product side, they were having issues. So it reacts with copper 2 oxide. We know that the formula for copper 2 oxide is CuO. How? Copper 2 plus, when they've told you that the oxidation state is 2 plus, right? This means that the overall charge, this is a monatomic ion, right? Monatomic ions, they have one overall charge. And oxide ion is going to be 2 minus. I told you whenever you have similar charges, you simply cancel it out and write whatever is left behind. So you will have CuO as the chemical formula of copper oxide. Then when the new product is formed, how do I know what product is formed? The question says aluminum reduces copper 2 oxide. This means that aluminum will be stealing away oxygen from copper and will reduce copper 2 oxide into copper metal. Okay. This means that copper metal will only be left and oxygen will be left. Supposingly, if I just simply write this down, right? I don't know the formula of aluminum oxide yet. I'm going to find it out. How? Aluminum is present in group 3 of the periodic table. You always have the periodic tables in your question paper. So you have to refer to that if you don't remember in which group that particular element is. Then you have to, since you see that they are not similar charges, you can't cancel it out. You're going to swap and drag. So this 2 is going to come as a subscript with aluminum. It becomes Al2, and then with oxygen, there's going to be 3, which is written as a subscript, plus Cu. Now, at the end of the question, 1 mark is basically to write down correct chemical symbols and correct chemical formula, okay, of the particular reactants and the products. Then the next mark is whether you are going to chemically balance this equation correct or not. Now you see that there are 2 aluminum here, okay, and 3 oxygens. This means I must be placing 3 here as a coefficient to balance it out, and 2 along adjacent to aluminum, right? And then I will or must be balancing this copper as well. Okay, now I have a chemically balanced equation. Now I am able to obtain this 2 marks. Is this point clear so far? This is the complete simple equation for this reaction, which you must be writing. If supposingly there was an additional phrase where the examiner states include state symbols as well. then a third mark would have been added to this. Okay, this whole question would have been allocated or allotted as 3 marks in total. Are we clear?
Yes, ma'am.
Okay. Look into the next one. The number of moles of this, and most of these questions, they were correct. This was also correct. Stop the students. Did anyone have any difficulties while going through this particular paper? Those who have attempted and submitted. Yes. Do you want me to ask any question? Do you want to ask any further questions or any queries are there?
Miss, I wanted to ask if oxidation state is the same thing as the valency.
Oxidation state is basically you can determine valency. You can say in this way that you can determine valency by looking at the oxidation state. But oxidation state particularly is for the transition elements, and we mentioned this as Roman numerals within the bracket. Okay, so you can say the valency in this regard, you can say that you can determine valency from the oxidation state. And generally, the valency comes out to be the same just like as oxidation states. Okay, it is going to be the amount of electrons one particular element has lost or it has gained. Okay, and secondly, oxidation states, they can vary. Why? Because the transition elements, they have this ability to control the number of electrons that they are losing, okay, which is why the oxidation state varies.
Okay.
But when you're going to mention this particular question, if you are asking in this context, supposing you are asking in this particular context, then you should mention oxidation number or oxidation state here, okay? Your terminology should be oxidation state or oxidation number, not variance.
Okay, Miss.
Okay. Look at this paper here. This is another question paper. Yes, some of the students, they were not able to contemplate the molecular formula of the compound. Molecular formula is actually the actual number of atoms which are present in that compound. So first you're going to identify what atoms or elements they are present. So carbon, oxygen, and hydrogen. I will just simply going to write all of the chemical formula symbols, and then after writing the chemical symbols, I'm going to count the number of carbon atoms. I'm going to mention it here as a subscript. Then for hydrogen, there are 1, 2, 3, and 3, total of 6. And then oxygens, there are again 3. So this is going to be your answer. Okay, it's the total number of atoms which are present within the compound. Most of the students, they were able to balance the equations. I am happy. Yes. Does anyone have any questions or any queries from this particular paper? Yes. One more thing I have to add in here. When you mention, when the question says define the following, define does not mean you have to answer in numerical terminology. If you add that particular thing, for instance, here it says Avogadro's constant. Avogadro's constant is basically it tells you a constant number or a fixed number of particles that one particular mole of any substance has. Okay, and that is 6.02 into 10 to the power of 23. Okay, particles. So that constant number or numerical value you may add, and if it is relevant to the answer, you won't be like giving a bad impression to the examiner. But if you simply write down, if I supposingly simply write down Avogadro's constant is 6.02 into 10 to the power, only the numerical value, this means I'm not following the command. Okay, the command word says define the following. Define the following means you have to just mention the simplest description of that particular terminology in one single statement, or maybe one to two single statements. But one single statement is more than enough to define a particular terminology, since this question only carries 1 mark. Okay, so no particular need to waste more time, right, in a complete long description of it. These two things you have to keep in mind. Then in this particular question, some of the students, they only find it out the number of moles, okay? And they actually forgot this part, that they have asked you to find out the number of molecules. How will you be able to find out or be able to depict or determine whether two different substances, they have same number of molecules, until and unless you are not able to find out the if you don't find out the total number of molecules? Obviously you have to find out the number of moles first. This is your first step. Then you have to carry forward, you have to multiply this with the Avogadro's constant, okay, that constant value, that constant numerical value. Then find out the total number of molecules each of these substances have. And lastly, you have to write a concluding statement that these two particular molecules, they have similar number of molecules or similar number of particles. And how do we know that? Whenever the number of moles, they are same, the number of molecules, they are also same. Okay, so this is the whole thing which I needed to discuss. Does anyone have any questions by far?
Miss, how do you exactly define a mole?
If you have to define a mole, if you look into the the presentation, the PowerPoint presentation, okay, simply look into the PowerPoint presentation. I have mentioned the how to define mole. Basically, mole is mole of a particular substance. It is actually the unit of measure. Okay, so it basically defines how much a particular substance has, or what is the quantity of that particular substance. Okay. I think I mentioned in your paper to rephrase or redefine your answer, right? So look into the PowerPoint presentation that I have uploaded onto Google Classroom. Okay, use that terminologies to redefine the answer.
Okay, I have one more question. In
Yes.
the first question, where we have to write the molecular formula, do we write it as like C2H4 then H, yeah, 4 then COOH?
No. Molecular formula is this is going to be the structural formula. Okay. If you mention the functional group as a separate entity, okay, and along with the hydrocarbon chain, this is going to be a structural formula. This again means that you're not adhering to and maybe you don't know how to write the molecular formula. How molecular formulas, they have to be completely the cumulative total number of atoms which are present in that particular compound, and simply write the total number of atoms. For instance, with whatever atoms or elements which are present within that particular compound, I'm just going to count them and just going to write the number as a subscript with their respective chemical symbols. Okay, that is your molecular formula. If you add in any functional groups at the end, this means this is not a molecular formula. This will be referred to as a structural formula. We will study this better in organic chemistry.
Okay, Miss.
All right, this is it for today's session. If anyone else has any questions regarding to their evaluations or anything else, you can ask me on WhatsApp. Okay, till take care. Allah Hafiz. Thank you. Bye bye.
Yeah, first.
Allah Hafiz.
Allah Hafiz, ma'am.
Allah Hafiz. Allah Hafiz. Take care.